In this video, we're going to be talking about intercept form. So intercept form, you should be familiar with. It's y equals a times x minus p times x minus q, where a is not equal to 0, and then the p and the q give you the x-intercept. So remember, when we have a parabola, these x-intercepts are where the parabola would cross the x-axis, and so y is always going to be 0. Okay, to find the vertex, find the average of p and q. To find the x-coordinate, since parabolas are symmetric, the x-coordinate of the vertex will be in between your x-intercepts. And then just like when we had standard form, we substitute that x value back into the function to find the y-coordinate. So starting with our first example here, we have f of x equals 1/2 times x minus 2 times x plus 1. So the x-intercepts, we look at these values inside the parentheses, and we take the opposite signs since the minus signs are part of the equation. So the first x-intercept here would be 2, 0, and then we would have negative 1, 0. So our p value is 2, and our q value is negative 1. So to find the x value of the vertex, we're going to take p plus q divided by 2. So x equals 2 plus negative 1 divided by 2. If we simplify that numerator there, we have 1 over 2. So I'm going to write that as a decimal, 0.5. Okay, to find the y value, everywhere we see an x, we are going to plug in x equals 0.5. So f of 0.5 equals 1/2 times 0.5 minus 2 times 0.5 plus 1. So remember, order of operations, we start with inside our parentheses. So we would have negative 1.5 in the first set and positive 1.5 in the second. And this is a self-check step here. You want to make sure that inside your parentheses you have the same numbers, with one being positive and one being negative. That helps you know that you have done everything correct up to this point. And so now we're just going to multiply across. So we have 1/2 times negative 1.5 times positive 1.5. So in your calculators, you could type all of that, and you get that y equals negative 1.125. So your vertex, the x value is 0.5, and the y value is negative 1.125. Okay, remember your axis of symmetry goes through the vertex, and it is a vertical line. So we write our vertical lines as x equals, then we take the x value of that vertex. So how has the parabola moved from 0, 0? Well, we look at our vertex and we see that it is a positive x value, so it's going to the right, 0.5, and then since a negative y value, it is going down 1.125. Okay, on our next example, we're going to do the same thing. Let's start with figuring out what our p and our q is. So looking inside the parentheses, our p, we take the opposite sign, so negative 3, and q would be positive 5, which means our x-intercepts, negative 3, 0, and positive 5, 0. Okay, to find the vertex, we're going to take the average. So x equals negative 3 plus positive 5 over 2. So x equals 2 over 2, so x equals 1. Remember, the x value of our vertex gives us our axis of symmetry, so our axis of symmetry here is x equals 1. Now everywhere we see an x in our problem, we are going to put in 1. So y equals 4 times 1 plus 3 times 1 minus 5. So do inside the parentheses first. 1 plus 3 is 4. 1 minus 5 is negative 4. And again, self-check here. We want inside those parentheses to be the same numbers, but opposite signs. And so we have 4 times positive 4 times negative 4. So y equals negative 64. So our vertex, x is 1, y is negative 64. How is that moving, translating on our graph? Well, it's going up 1 since x is positive, and then since y is negative, it's going down 64. Okay, so for questions 3 and 4, we want to state the x-intercepts, find the vertex in the axis of symmetry, and then graph the quadratic by plotting additional points and using symmetry, and then state the domain and range, and then find the average rate of change over the interval negative 1, 3. So we have a lot to do here. Okay, let's start with stating the x-intercepts. So our p is positive 3, and our q is positive 1. So the x-intercepts would be 3, 0, and 1, 0. Okay, so we stated the x-intercepts for our first one. Now we want to find the vertex and the axis of symmetry. So starting with the x value of the vertex, we're going to take 3 plus 1 divided by 2. So 4 divided by 2 gives us 2. So that already gives us our axis of symmetry. We know is x equals 2. Since the x value of the vertex tells us where that axis of symmetry is. All right, now everywhere that we see an x, we're going to put in 2 to solve for the y. So f of 2 equals 2 times 2 minus 3 times the quantity 2 minus 1. So doing inside the parentheses first, 2 minus 3, we get negative 1. 2 minus 1, we get positive 1, and we still have that 2 out in front there. So self-check, make sure inside those parentheses you have the same numbers with opposite signs, and then you can just multiply those 3 numbers together. So f of 2 equals 2 times negative 1, which is negative 2, times positive 1 is negative 2. So our vertex is 2, negative 2. Okay, so let's plot these points that we already have. So starting with our x-intercepts, we know we have over 3 up 0, and then over 1 up 0. And then our vertex is at 2, negative 2. And since we know what parabolas look like, that is already enough for us to connect our points here. We're going to go up and up. And our axis of symmetry would go through that vertex, that vertical line, at x equals 2. Okay, so domain and range. I'm going to write it here. Domain here. Remember, domain is the x value. So looking at the graph from left to right, if we start on the left, we can see that this graph is going all the way to negative infinity, and then to the right it also keeps going. So our domain is negative infinity to positive infinity, and our range, we're going to look from bottom to top. So starting at the bottom here, our range is our y values. The first point we see is right here at the vertex, and the y value for this point is negative 2. Since that point is on the graph, we're going to put a bracket, negative 2, and then it goes all the way up to positive infinity. So the y value of your vertex should always be included in the range for your parabolas. Okay, the last thing we need to do here is find the average rate of change. So let's get a new color here. Okay, so we want the average rate of change over the interval negative 1, 3. So remember this interval here gives us the x values for our rate of change. So we're going to make our baby table, and the x values are negative 1 and 3. So now we need to find the y values that go with it. Well, looking at our x-intercepts, we already know what y is when x is 0. When x is 3. When x is 3, y is 0. And so now we need to figure out the y value when x is -1. So we're going to use our equation and put in -1. So again, starting inside the parentheses, keeping that 2 out front, -1 minus 3 gives us a -4. -1 minus 1 gives us -2. And since we aren't dealing with the vertex here, those parentheses do not have to be the same. So we're going to take 2 times -4 times -2. We have a negative times a negative, so we should have a positive, and it is positive 16. And I'm going to fill that in my table. Okay, and so now to find our average rate of change, we're going to take the change in y's over the change in x's. So we can do 0 minus 16. Since I started with the bottom for the y's, I'm going to start with the bottom for the x's. So 3 minus -1. When we have minus and negative, that becomes positive. So we have 0 minus 16 over 3 plus 1 gives us -16 over 4. And when we divide that, we get -4. So our average rate of change here is -4. Okay, pause it and try to do this next one on your own, and then once you have that, we will go through it together. So starting with stating the x-intercepts, look inside our parentheses here to find the p and q. So p is -2 and q is +2. So the x-intercepts, -2, 0, and +2, 0. Okay, now we want to find the vertex in the axis of symmetry. So we're going to take the average of those x values, so -2 plus 2 over 2, getting ahead of myself here. So -2 plus 2 is 0 over 2 gives us 0. So the axis of symmetry is x equals 0. Now we want to find the y value of the vertex. So everywhere we see an x, we're going to put in 0. So f of 0 equals, we still have that negative out front, 0 plus 2 times 0 minus 2. Still have that negative out front, and we're going to simplify inside the parentheses. So 2, and then -2. So now we're going to multiply those three numbers together. So -1 is in front there, times 2 is -2. -2 times -2 gives us +4. So our vertex is over 0, up 4. So let's go ahead and plot the points that we have. So over 0, up 4. And then our x-intercepts and notice how our parabola is opening down here, and we started with a negative in our equation. Up here on number 3, we had a positive a value and our parabola was opening up. So I'm going to connect this here. Okay, there's our parabola. Now I want the domain and range. So domain left to right, it covers every single x value. And then the range bottom to top, if we look at the bottom here, for our y values, it's pointing down to -infinity to start with. Okay, and then bottom to top, it's going up, 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 up until it reaches this vertex. This is a maximum point here. And that y value is 4. So the range is from -infinity to 4, and it has a point there, so it has a bracket. Okay, so again, the y value of your vertex is involved in your range in some way. All right, last thing we need to do, find the average rate of change for the interval -1 to 3. All right, so again, that interval gives us the x values. And we want -1 to 3. Okay. So none of our points that we have already found have an x value of -1 or 3. So we are actually going to need to find both of those. So starting with x being -1. Everywhere we see an x, we're going to put in -1. Okay, simplify inside the parentheses first. Since we're not dealing with the vertex, those numbers do not have to be the same. And so when x is -1, we get +3. Okay, now let's do it for when x is 3. Everywhere there's an x, we're going to put a 3, leave the negative out front, simplify inside the parentheses first. So when we multiply those three numbers together, we get -5. Okay, and if we look at our graph, you can see that when x was -1, our y actually landed right on 3. And then when x was 3, it's not even on our graph. All right. So finding the average rate of change now, I'm going to go ahead and erase this so that I have room. Okay, so finding the average rate of change, we're going to find our change in y over our change in x. So if I have 3 minus -5, okay, I started with that top y value, so now I'm going to start with the top x value. So -1 minus 3. When we subtract a negative, that becomes plus. Okay, so 3 plus 5 gives us 8. -1 minus 3 gives us -4. And so our average rate of change is -2. Okay, and if we look from the point when x is -1, and then 3 -5 would be down here, we can see that we have that negative slope.